Alright, so in this problem, I have 9 to the power of x plus 15 to the power of x is equal to 25 to the power of x. So I'm going to first start by dividing both sides by 9 to the power of x. So now this results in 9 to the power of x over 9 to the power of x plus 15 to the power of x over 9 to the power of x is equal to 25 to the power of x over 9 to the power of x. Now 9 to the power of x and 9 to the power of x cancel out. So I get 1 plus 15 to the power of x over 9 to the power of x is equal to 25 to the power of x over 9 to the power of x. Now, if I have something in the form a to the power of m over b to the power of m, this is the same thing as a over b to the power of m. So 15 to the power of x over 9 to the power of x, that's going to equal 15 over 9 to the power of x. And 25 to the power of x over 9 to the power of x, that's going to equal 25 over 9 to the power of x. And now, 15 over 9 simplifies to 5 over 3. And 25 over 9, that simplifies to 5 squared over 3 squared. So now 5 squared over 3 squared, that's going to equal 5 over 3 squared. Now I have this to the power of x. Now if I have something from a to the power of m to the power of n, same thing as a to the power of n to the power of m. So 5 over 3 squared to the power of x, that's the same thing as 5 over 3 to the power of x squared. Now I'm going to let 5 over 3 to the power of x equal to the variable y. So I get 1 plus y is equal to y squared. And if I subtract y and 1 on both sides, I get y squared minus y minus 1 is equal to 0. So I get a quadratic equation, and to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 1, and c is negative 1. So I get y is equal to negative of negative 1 plus or minus the square root of b squared, which is negative 1 squared, minus 4 times a times c, which is negative 1, all over 2a, so 2 times 1. This is equal to 1 plus or minus the square root of negative 1 squared, which is 1, minus 4 times 1 times negative 1, which is plus 4, all over 2, which is equal to 1 plus or minus the square root of 5 over 2. Now remember how we let 5 over 3 to the power of x equal to y. So I have 5 over 3 to the power of x equals to 1 plus or minus the square root of 5 over 2. So now this gives me two equations. I have 5 over 3 to the power of x is equal to 1 plus the square root of 5 over 2, and 5 over 3 to the power of x is equal to 1 minus the square root of 5 over 2. So 5 over 3 to the power of x equals 1 minus the square root of 5 over 2. Well, 1 minus the square root of 5, that's going to be a negative number. And a negative number divided by 2 is still a negative number. And notice how we have a positive number to the power of another number here. And you can't take the power of a positive number and make it equal to negative, so there's no solution for this. Now for 5 over 3 to the power of x is equal to 1 plus the square root of 5 over 2. To solve this, I'm going to first start by taking the log on both sides. So I have log 5 over 3 to the power of x is equal to log 1 plus the square root of 5 over 2. And if I have something in the form log a to the power of b, I can move b to the front, so it's going to equal b times log a. So in this case, I have log 5 over 3 to the power of x, and I can move x to the front, so I get x times log 5 over 3 is equal to log 1 plus the square root of 5 over 2. Now if I divide both sides by log 5 over 3, these two cancel out, and I get x is equal to log 1 plus the square root of 5 over 2 over log 5 over 3. Alright, so in this video, I'm going to solve the equation 1 to the power of x is equal to 2. So, before we even start solving this, if, let's say x is equal to 1, then I have 1 to the power of 1, which is equal to 1. And if x is equal to 2, then I have 1 to the power of 2, which is also equal to 1. And you can go even 1 to the power of 10 is still equal to 1. So you may be thinking, what possible value of x can make 1 to the power of x equal to 2? So let's try solving this. What I'm first going to do is start by taking ln of both sides. So I get ln of 1 to the power of x is equal to ln of 2. And ln is the same thing as the natural log. And the reason I took the ln on both sides is because it comes with a property that states that if I have something in the form ln a to the power of b, I can move this exponent b to the front, so this turns into b times ln a. So in this case, I have ln 1 to the power of x, and I can move x to the front. So I get x times ln 1 is equal to ln 2. And you may be thinking, we could just divide both sides by ln 1 and x would equal ln 2 over ln 1. However, the only problem with this is that ln 1 is equal to 0. And remember, anything divided by 0 is undefined, so this would be undefined. So we know that this equation has no real solution, but it could still have imaginary solutions. So to actually solve this, I'm going to use something known as Euler's formula. And basically what this formula is if I have something in the form e to the power of I times theta, this is equal to cosine of theta plus I times sine of theta. And I know to many of you watching this video, this may just sound like a bunch of gibberish, but just hang on. So let's say that theta is equal to 0, right? Say that theta equals 0. So now I get e to the power of I times 0 is equal to cosine of 0 plus I times sine of 0. Cosine of 0 is 1 and sine of 0 is 0. So I get this all is equal to 1. Now, what if we say theta is equal to 2k pi? And k is just a substitution for all real numbers. So now I get e to the power of I times 2k pi is equal to 1. Because all we did was we just substituted theta in for 2k pi into this same thing. So now, because this is equal to 1, we can remember our first equation, which we started with 1 to the power of x equals 2, we can substitute in this for 1, meaning I get e to the power of I times 2k pi to the power of x is equal to 2. So just think of this as 1. So I have basically 1 to the power of x equals 2. And now with this, I'm going to take the ln or natural log on both sides. So I have ln e to the power of I times 2k pi to the power of x is equal to 2. So I'm going to now bring this x down using property of natural logarithms. So I get x times ln e to the power of I times 2k pi is equal to 2. is equal to ln of 2, because if you take ln on one side, you have to do the other side. And now I can also move I times 2k pi to the front. So I have I times 2k pi times x times ln e is equal to ln 2. ln e is simply equal to 1. So I get x is equal to ln 2 over I times 2k pi. And now I'm going to multiply this by I over I. So I get x is equal to negative I times ln 2 over 2k pi, because I squared is negative 1. So this is my solution.